Dear students, in the first part of steam boiler, you were introduced to some important terms related to boilers. Then the essentials of a good steam boiler and the factors on which selection of a boiler depends were discussed. And then fire tube boilers and water tube boilers and their comparison was discussed in detail. Now, in this part, we are going to study boiler mountings and boiler accessories. On the last one, I discussed what are boiler mountings and accessories. Now, in detail, we'll see what are these and how they work. Boiler mountings and accessories are the devices required for proper, satisfactory, and efficient functioning of a steam boiler. What are boiler mountings? These are fittings which are mounted on the boiler for its proper and safe functioning. What does it mean? It means these boiler mountings are essential parts of boilers, and if these are not present in the boiler, then the proper functioning of boiler may get affected. Therefore, these are essentially mounted on boilers. Some of these have been listed here, which are important from subject point of view. We'll discuss one by one. Before that, let us see what is boiler accessory or what are boiler accessories. These are the devices which are used as integral part of a boiler to help in increasing the efficiency of a boiler. What does it mean? It means these are not essential parts of the boiler, but if integrated with boiler, they are capable of increasing the efficiency of the boiler. There are a number of accessories existing, but from subject point of view, we'll be discussing some of them. Under boiler mountings, first of all, let us discuss what is water level indicator. Water level indicator is a device that indicates the water level inside the boiler and also acts as a safety device. This is shown here in this figure. It consists of 3 valves. See here, this is valve 1, valve 2, and valve 3, and there is a glass tube here. Now, steam valve V1 connects the glass tube, this glass tube, with the steam space. See here, it is cylinder of the boiler, cylindrical part of the boiler, where water is filled, cylinder shell or boiler shell, where water is filled in part of it, and in the upper part there is steam. This is the steam which has been converted from water. Right now, steam part is connected to this glass tube through valve V1. Similarly, this water part is connected through valve V2 to this glass tube. The steam valve V1 connects the glass tube with the steam space, and valve V2 connects the glass tube with water in the boiler. Now, there is a valve V3. This is called drain valve. At frequent intervals, this valve is opened just to check whether steam and water valves are clear and also to remove any sediments which may be there here at valve V1 and V2. Now, in case if the glass tube is broken, this glass tube which indicates the water level, it is broken, 2 balls are after V1 and V2 close the ends of the glass tube. There are balls present here which automatically are moved to this end to close, so that no steam may pass through this and no water may pass through this. This valve will come to this position and close this path or passage. Right? Here you see another part which is called guard tube. This guard tube is to protect the worker or observer when glass tube is broken due to some accident. Then this is just to protect it or stop the small parts of glass tube from going here and there. The glass tube can be easily replaced by closing the steam and water valve and opening the drain valve. So before the glass tube is opened, these two valves will be closed, drain valve will be opened, and then this tube will be replaced with the help of these nuts. Another mounting is pressure gauge. The device used to measure the pressure of steam inside the steam boiler is Gordon's pressure gauge. It is one type of the pressure gauge, Gordon's pressure gauge. It consists of an elliptical elastic tube ABC bent into an arc of a circle, as shown in the figure. Here you can see this is the tube. See, ABC. This is the tube, elliptical tube, which is bent into an arc. One end of this tube is fixed and connected to the steam space here. See here. This is the boiler part from where steam is coming into this pressure gauge and entering into this tube. And the other end is connected to a sector through a link. This is the sector, and there is a link here. This end of the tube is connected to this sector through this link. And on this sector, you see this pointer, black color pointer is there. When steam flows into the tube, it increases its pressure. When steam flows into this, it increases its pressure and tube tends to straighten itself because of the pressure. And to become circular, this tube tries to become circular and the sector arrangement is there due to the straightening of the tube, which is connected to this sector via this link. Due to the straightening of this tube, this sector rotates the pointer. This pointer moves over a calibrated scale. See here, it is the calibrated scale which will show the gauge pressure, right? So as the steam flows into this and this tries to straighten itself, depending on the pressure, this pointer will move and indicate the exact pressure. Now, safety valves. On the last time I discussed that there are safety valves provided in the boiler. What are safety valves? A safety valve is the device attached to the steam drum for preventing explosions due to excessive internal pressure of steam. Every system or steam drum is designed to withstand a certain pressure. If inside pressure increases or exceeds that limit, then there is a danger of explosion taking place, right? So to avoid that, these safety valves are provided in the boiler. Function of safety valve is to release the steam when pressure inside the boiler exceeds the design level. So whenever pressure exceeds, automatically this safety valve will open and release some steam till it reaches the limiting value. As soon as the pressure comes below the limiting value, automatically this valve will be closed. There are different types of valves. One is lever safety valve, dead weight safety valve, spring loaded safety valve, etc. And as per the requirement and depending on the type of the boiler, these are used. First two types of safety valves are usually employed with stationary boilers. Lever safety valve, dead weight safety valves, these are used with stationary boilers, means big boilers. Spring loaded safety valve is generally used with locomotive and marine boilers. Now, what is lever safety valve? As the name indicates, there is a lever in this valve on which on one end there is a load, the other end is connected to the valve seat. From one end of this, steam enters A lever safety valve as shown in the figure serves the purpose of maintaining required pressure inside the steam boiler by the way of lifting the valve from its seat. See, this is the valve, this is valve seat, and so far as inside pressure is not much or has not exceeded its limiting value, this will not be lifted. This load will be provided accordingly, according to the permissible pressure, right? Corresponding to the permissible pressure, there will be a load. This is a slotted lever guide in which this lever may move up and down, right? Now, the lever safety valve has a valve body with a flange, and the bronze valve seal is screwed to the body. This is the flange which will be screwed to the boiler body, right? So when pressure exceeds inside the boiler, this will lift this valve over the valve seat, and there will be a space between valve seat and valve from where steam will be released, right? So this entire load will be lifted up in this slotted guide. This lever will be lifted, and as soon as the pressure inside decreases the limiting value, automatically due to this load, the lever will come down, and again this valve will be closed and escape of steam will stop, right? Using the bronze valve and seat of the same material, rusting is avoided. This bronze material is used just to avoid rusting. Load acts on the valve through the strut. There is a strut here which is pressing this valve, right? So far as the pressure inside is equal to or below the limiting value of pressure, this strut will stop the valve from lifting up. If the steam pressure exceeds the safe limit, the valve is raised from its seat and steam escapes till the pressure falls back to its normal value and the valve returns to its original position. This I have already discussed. Now, the other type of valve is deadweight safety valve. So before discussing deadweight safety valve, let us discuss one of the disadvantages of lever safety valve. The disadvantage of this valve is that it admits of being tampered with, and the effect of a small addition to the weight is magnified considerably in its action on the valve, right? So even if a small difference is there in the weight that was provided on the lever, there will be considerable magnified action on the valve. So care has to be taken to provide exact required weight on the lever. Now come to deadweight safety valve. It is made of gunmetal. See here, this is the valve of gunmetal, and these are the weights provided on both sides. This is the weights carrier or load carrier, you can say. This is the path for steam entry. And this is flange. With the help of this, it is tightened on the boiler, and when steam pressure inside exceeds, this acts on this valve. This lifts. Steam pressure is more than this corresponding weight, right? Then this will be lifted up and steam will escape from here, and through this path steam will exit to the atmosphere, right? So as soon as inside pressure comes down, automatically due to this weights, again this load carrier will come down, pressing the valve, and this valve will be closed. So the same thing is written here. If the pressure of steam exceeds the normal pressure, the valve is lifted from its seat and allows the steam to escape through the discharge pipe. Next one is spring-loaded safety valve. As already discussed, this type of safety valves are used for locomotives and marine boilers. It is loaded with spring made of steel rod. See, here it is the section of the spring shown in the diagram. It is in the helical form, placed under compression. Now, here in this case, there are two valves and two valve seats. This is lever, similar to the lever safety valve. And under the compression, these valves are closed initially so far as the pressure inside the boiler is below the limiting value. It has a cast iron body connected to the boiler. This is the body that is with the help of this flange connected to boiler. Now, as soon as this steam pressure exceeds, this lifts this valve, and due to the lifting of the valve against this spring pressure, steam will escape, and as soon as inside pressure decreases, again due to this spring pressure, these valves will be closed, right? So it is provided with two separate valves, as I discussed, of the same size with their seats in the upper ends of the two hollow valve chests united by a bridge and base. As I already discussed, base is bolted to the top of the boiler over the firebox. With the help of this base, it is mounted to the boiler. When the steam pressure under valves exceeds the normal working pressure and downward spring force, the valve opens and lets the steam go out. And spring brings the valve to close position when pressure is reduced to working level. This I've already discussed, right? I hope you understood it. Now, another mounting is steam stop valve. As the name indicates, the basic function of steam stop valve is to control the flow rate of steam from the boiler and to shut off steam flow completely if required. See this diagram here. Body of the steam valve is stop valve is made of cast iron. This body is made of cast iron or cast steel, and there is a valve here, see, and valve seat. These are made of gunmetal. There is a spindle passing through this valve, through the gland, and this is stuffing box. And this spindle can be rotated by means of a hand wheel here at the top to open and close the valve. As you rotate it in the anti-clockwise direction, the spindle will go up and valve will be separated from the valve seat, and you say that valve is opened to allow steam to go out. Whatever steam will go out will go via this passage into the atmosphere. So whenever you want to, not to atmosphere, to the required prime mover, right? So this is the steam coming from the boiler in generally saturated state or superheated state. When this is opened with the help of hand valve, it will allow steam to go into this direction. So if it is completely open, there will be complete opening. If you want to control the flow rate, it will be partially opened. With the help of this hand wheel, you can control the flow. Another one is blow off cock. What is blow off cock? It is a device, the function of which is to empty the boiler if required. So whenever for maintenance purpose or for any other purpose, you want to empty the boiler and remove all the water, the part that is provided is blow off cock. And also to discharge mud and scale, which might have been accumulated at the bottom of the boiler, you require this mounting. This blow off cock is fitted to the bottom of boiler drum and consists of a conical plug fitted to the body. See here, this is the conical plug fitted to the body, and here there is steam passage. If this is closed, steam cannot escape from this, or water cannot escape from this. But as soon as you rotate it and allow the fluid to pass through it, it will go out and everything can be removed from the boiler. So if it is provided at the bottom part, then its opening will permit the boiler to get emptied, even to remove mud and scale, etc. Right? Here also this plug stem passes through a gland and stuffing box, and there are two vertical slots on the inside of a guard for the box wrench to be used for operating the cock. So here, box wrench, with the help of box wrench, when you rotate it, this opening will be in line with this steam flow line or pipe, right? Now another part is fusible plug. What is fusible plug? It is used to put off the fire in the boiler when the water level in the boiler falls below an unsafe limit. If water level goes down very much, then it becomes dangerous for the boiler walls, boiler tubes, etc., and they may exceed the limiting temperature and may get distorted. To avoid any danger, a fusible plug is provided because the exposure of fire tubes to steam may cause melting, right? So fusible plug is fitted to the crown plate of the furnace. At the furnace crown, this fusible plug is provided. It consists of a hollow gunmetal plug, as you can see here, right? And it is screwed to another hollow gunmetal plug, right? See here. A third hollow gunmetal plug extended as ring at the top is made up of fusible metal. This is fusible metal, right? So whenever this fusible metal is protected from fire by the flange on the lower end, right? Now when water falls below the limit, this fusible plug will be exposed to steam, because if water level comes down below this point, then this fusible plug will be exposed to steam, and on one side it is exposed to steam, and on other side it is exposed to the flue gases, hot gases, which are produced out of combustion process on the other side. This increases the temperature of the gunmetal and causes melting of the plug. And due to this melting, there will be space for the steam or water to enter here. As soon as steam and water enter from here, it falls on the furnace directly and stops the firing, put off the firing, right? So this is how it protects the boiler from fire or any other danger. Now, another mounting is feed check valve. Feed check valve is a non-return valve. Here it is. Water enters from this side for going into the boiler drum. There is a feed check valve. What is the purpose of this valve? To regulate the supply of water pumped into the boiler. This valve has its spindle lifted before the pump starts. This is the spindle, right? It is lifted to the shell slightly below the normal water level of the boiler, and the body of the valve is made of brass casting and spindle is made of Munz metal. This flange is bolted to the end of the boiler at a point from which the perforated pipe leads the feed water, and this pipe distributes the water in the boiler uniformly, right? So water enters from here and passes through this non-return valve. Once the boiler is filled with water, this valve always remains closed due to the back pressure of the water. and does not allow the water to flow back to the pump side, right? The water cannot go to the pump side because of this non-written law. Now we have discussed various types of mountings. Now let us see what are accessories. So before this is a block diagram which shows how these mountings or accessories are arranged. This is the boiler and all mountings are mounted to this boiler. Now fuel is supplied to boiler, air is passed into the combustion chamber, due to which combustion takes place. Flue gases will be produced. Those gases will heat up the water and convert it into steam. That steam, when comes out of the boiler, enters into a part called superheater, where it will be superheated, or it will be brought from dry state or wet state to superheated state. Because in superheated state, steam behaves like a perfect gas, and when it goes into the prime mover, there will be perfect working over the turbine blades or steam engine piston. There will be no danger of getting rusted, right? So superheated state steam is sent to the application. Application means whether steam engine or steam turbine, right? Now these gases which are coming out of the boiler have heated this steam to superheated state, and these still have energy, will enter into another device called economizer. Here water which is going into the boiler is entering, right? So these flue gases give their energy to this water, and water temperature is increased, right? So that will go into the boiler. ये एयर लिखा है, it's not air, it is water basically. एयर का पाथ अलग होगा, right? ये ऊपर ये flue gases after giving their energy to water in the economizer enter into another part which is called air preheater. Air from the atmosphere enters into this and gets heated up, and the hot air enters into the boiler, so that when hot air goes into the combustion chamber, combustion process will be very smooth, right? So for that purpose, we are using energy of the flue gases. पहले एनर्जी फ्लू गैसेस ने बॉयलर में पानी को कन्वर्ट कर दिया स्टीम में, अब वो बाहर जा रही है चिमनी की ओर, लेकिन जाने से पहले एटमॉस्फेयर में इतनी सारी एनर्जी लेकर अपनी थोड़ी एनर्जी उन्होंने यहाँ दे दी सुपर हीटर में, स्टीम को सुपर हीटेड स्टेट में ले आए, वो स्टीम चली गई अपने एप्लीकेशन में, यानी कि किसी भी प्राइम मूवर पे जहां भी यूज होना है उसका, और ये फ्लू गैसेस अपनी थोड़ी सी एनर्जी देने के बाद अभी भी उनमें एनर्जी बची है, वो इकोनोमाइजर में आ गए। इकोनोमाइजर में ये फीड वाटर हमने पास कर दिया, फीड वाटर को उन्होंने एनर्जी दे दी, फीड वाटर थोड़ा गर्म हो गया, जिससे जब ये बॉयलर में जाएगा तो फ्यूल कम लगेगा क्योंकि ऑलरेडी हीटेड वाटर इसके अंदर एंटर कर रहा है। देन आफ्टर गिविंग their energy, still there is energy in the flue gases which will be used in heating the air which is going for combustion purpose. तो इसमें उस एयर को भी हीट करने के बाद फिर ये चिमनी में निकल जाती है, flue gases go into the chimney from where they will be left for atmosphere. Now one by one you can again see superheater is used to increase the temperature of saturated steam without raising its pressure. So at same pressure, its temperature will be increased. It is usually placed in the path of hot flue gases in the furnace, and the heat of the flue gases is first used to superheat the steam. It is not necessary, but this, as I have shown in the last diagram, superheater may be provided at a later stage after giving heat to water to convert it into steam, or it may be given before that, so that whatever steam is going out of the boiler will be heated first to superheated state, and then those flue gases will enter into the actual boiler tubes to heat up the water, right? Now steam enters into the downstream tubes and leaves at the front header. The overheating of superheated tubes is prevented using a balanced damper which controls the flue gases. So there is a damper provided here which controls the flue gases. So these flue gases, when passing over these tubes through which steam is coming in saturated state, will leave in the superheated state. तो ये इधर से फ्लू गैसेस आई, ये सुपर हीटर है, इसमें इसके ऊपर से निकल गई, उसके बाद फ्लू गैसेस का जो भी यूज है उसके लिए वो चली जाएंगी आगे, राइट? Now as I said, another accessory is economizer. It is a device used to feed water with the excess heat in the flue gases before leaving through the chimney to improve the efficiency of the boiler. जो फ्लू गैसेस चिमनी में जा रही हैं अपना काम करके, उनकी रिमेनिंग एनर्जी को इस फीड वाटर को गर्म करने में यूज किया जाता है, और वो किया जाता है इकोनोमाइजर के अंदर. So what is an economizer? It has a number of tubes. It is made of transverse section with vertical water tubes. From one end, feed water enters into these tubes and move upwards and leave from here. Now flue gases pass over these tubes from one end. इस तरफ से फ्लू गैसेस के ऊपर पास हो रही हैं, यहाँ से निकल रही हैं, and during this passage these gases give their energy to the feed water so that when feed water comes out of this, its temperature is raised considerably, right? अब ये सब क्या है इसके ऊपर जो लगे हुए हैं? To keep vertical tube free from the deposit of soot. अब जो फ्लू गैसेस आ रही हैं उनके अंदर कार्बन भी होगा, सूट भी होगा, जो कि इसके ऊपर से पास होते समय इसके ऊपर चिपक जाएगा ट्यूब्स के ऊपर, एंड ट्यूब्स के अंदर से पानी जा रहा है, तो फ्लू गैसेस जब अपनी एनर्जी देंगी, अगर उनके ऊपर कार्बन या सूट चिपका होगा, हीट ट्रांसफर will not be much effective, right? So always these tubes should be clean from outside so that transfer of heat from flue gases to the feed water may remain effective. For that purpose, these scrapers are provided on each tube. ये जो दिखाई दे रहे हैं ये scrapers हैं which are connected with the help of rods and chain passing through this pulley. These continuously move, and these scrapers are grouped together and coupled by rods and chain with which automatically reverse when they reach the top or bottom end of the tube. जैसे ये नीचे आते हैं ऑटोमेटिकली ऊपर चल देते हैं और साफ करते जाते हैं ट्यूब को, और फिर ऊपर जाते ही फिर नीचे चलने लगते हैं. On each tube there is a scraper, and these scrapers are kept in motion continuously when the economizer is in use. जब तक ये यूज में है कंटिन्यूसली ये ऑपरेट करते रहते हैं, जिससे ये ट्यूब साफ रहती हैं, फ्लू गैसेस पास होती रहती हैं, एंड फ्लू गैसेस गिव देयर एनर्जी टू वाटर. Air preheater, as I discussed a few minutes back, an air preheater is used to recover heat from the exhaust flue gases and is installed between the economizer and chimney. तो इकोनोमाइजर के बाद एयर प्रीहीटर लगा देते हैं, क्योंकि वहां से जब फाइनली चिमनी के लिए गैसेस जा रही हैं, फ्लू गैसेस, वो अपनी हीट जो एटमॉस्फेरिक एयर है उसको एक्सट्रैक्ट करके उसको देती है. Air required for the purpose of combustion is drawn through the air preheater and its temperature is raised when passed through ducts. The air passed through the tubes of the heater internally while the hot flue gases are passed over the tubes. तो क्या होगा, ट्यूब्स के अंदर से आपने एयर को पास किया, उनके ऊपर से गैसेस गई तो एयर गर्म हो गई. That preheated air gives higher furnace temperature which results in more heat transfer to water and reduces the fuel consumption. तो कंबशन स्मूथ हो जाता है, फ्यूल कंजम्पशन कम हो जाता है, राइट? So with this we finish boiler explanation of boilers, boiler mountings and boiler accessories. I hope you understood all. We'll be discussing various types of boilers in the next class. Till then, bye. Good luck.